Well, good day, everybody. This is Joe Van Cleve, and welcome back to the Abacus series. This is part 6. And in today's episode, I'm going to demonstrate for you the easiest way to learn to use the abacus. This is called the counting method. Stay tuned. Well, preparatory to getting into demonstrating the counting method of addition and subtraction, I wanted to first introduce you to these two books. And if you're in any way connected with the world of the abacus, and if you ever hear anybody talking about Kojima's books, what they're referring to is these two little books that were written by Takashi Kojima, a soroban, Japanese soroban expert. His first book was called The Japanese Abacus, Its Use and Theory. I first acquired a copy of this book back in the early 1970s. It was an older style cover. And then his second book was called Advanced Abacus Theory and Practice. Together, both of these books lay out the fundamentals and really a lot of the advanced techniques for using the 1/4 Japanese soroban version of the abacus in the way that the Japanese have taught it in the 20th century. Now, one of the challenges of learning the abacus the Japanese way is that it involves the concept of complementary numbers. And this is one of the things that is the most difficult for beginners to grasp, and it requires a lot of practice in order to know how to use complementary arithmetic operations when entering numbers or adding or subtracting numbers. And one of the beauties of this method I'm going to show you today, what I call the counting method, and another method a little bit more advanced called chunking. Those two methods, you don't need to use any complementary arithmetic operations. You don't need to know complementary numbers. There's only 3 simple rules. Well, I have an assortment of abaci laid out here from the Chinese 2-5 style, and this is actually a Japanese build, Chinese configuration, 2-5. The Japanese evolution of that was the 1-5, and then the more recent early 20th century, the 1-4. This is the most modern abacus, the Japanese soroban. Then there is the Russian 10-beat abacus and this child's abacus. So all these 5 different styles of abaci, I'm going to start by showing you how to do the counting method of addition on the Chinese 2-5, because this particular configuration, 2 beads in the upper part and 5 beads on the lower part of each place value, this is probably the most common abacus configuration that you'll see if you're shopping around for an abacus in a thrift store or an antique store or whatever. Although I personally like the 1-4 abacus, the most modern Japanese style, but we're going to cover the 2-5 today, and we'll cover how to do this same counting method with the 10-beat abacus, the Russian abacus, and the 1-4 later on. But for now, let's start with the 2-5 abacus and show you the counting method of addition. Okay, this is the Chinese abacus configuration. There is a dividing bar separating the upper part from the lower part. Each rod is a place value, and you can choose to put your units any one of these places you want. We're just going to start our units on the right-hand most rod here, just for simplicity's sake. You have a total of 7 beads on each rod, and the way this works is the lower bead of each rod represents one of that unit. So these are representative of ones individually. These would be tens, these would be hundreds, etc. And each bead on the upper part is worth 5 of that place value. Now, you might notice that if you were to count all of the beads, it would count to a total of 15, and that seems not consistent with the base 10 number system, and that is true. And the reason why you can count up to 15 on each rod of the Chinese abacus is because they used it centuries ago for their monetary system, which was base 16. But for now, we're just going to use this for simple decimal calculations, addition and subtraction. So when you clear the abacus so it's not representing any numbers, you simply move all the numbers away from the bar, and it's typically done in the 2-step fashion I just showed you. Let's say the abacus is all messed up. You simply tilt it like that and then run your finger right over the top of the bar, pushing the upper beads up, and that is how you clear the abacus. So it's cleared for operation. This is our units column, this is our tens, this is our hundreds. Now, we have 3 things we need to understand in order to do addition and subtraction, and mainly today I'm going to talk about addition. So the first thing is you have to be able to count from 1 to 10. And I'm going to show you that right now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay? Let's go over that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how you would count from 1 to 10 on the Chinese abacus. Now, the second concept I'll lead into, you actually saw me doing. I didn't mention it, but it's called regrouping. Regrouping is when you take the sections of the rod, either the upper or the lower, and you've used up all the beads in that section, or you've entered all the beads in that section. You're going to want to erase those beads and represent them with the next higher unit. And let me show you what I mean. If I'm counting to, when I get to 5, I clear those 5 out and I represent those 5 with a single 5 bead. That's called regrouping. I've simply regrouped the beads. Regrouping permits me to continue counting. 6, 7, 8, 9, 10. When you get to 10 on a rod, also you need to regroup. And I do that by a single 10 bead on the next row to the left, and I clear those out. That's also regrouping. The third way that you have to regroup on the Chinese abacus is if you have 2 5 beads in the upper part of a rod. You have to clear those and represent them by also 1 bead in the next column to the left. The third concept you need to know to operate the Chinese abacus is you need to hold 2 numbers in your head at once. The one number is the number you're trying to add, and the next number is the number you're currently at in the count. And what I mean by the count is the way we're going to do addition on the abacus, the simplest possible way that anybody can do, is called the counting method. So let me just demonstrate it for you. Let's try the problem 2 plus 3. I'm going to enter the number 2, okay? I entered each one single bead at a time. And the next step is I'm going to enter the number 3 by counting the beads on individually. 1, 2, 3. And my answer is 5. Now, you'll notice that when I was counting that second number on, I had to remember 2 numbers. I had to remember, what number am I counting up to? Number 3. And the second thing is, at each step of the operation, I had to remember, what is the current count that I'm at? I'm at 1, and I'm trying to go to 3. I'm at 2, and I'm trying to go to 3. And now I'm at 3. Okay? So, I know how to enter numbers. And now I know how to count on the abacus, and I can count up one at a time to a number that I'm supposed to get to. The third thing I need to do is to regroup. So let me show you a little more complex problem using all 3 of those principles: counting, regrouping, and remembering numbers. Let's try the problem 4 plus 3. 1, 2, 3, 4. Now I'm going to enter my 3. 1, regroup, 2, 3. Okay? 4 plus 3 is 7. 5 and a 2. That represents 7. Let's try 3 plus 4. I enter my 3. You'll notice I can enter the number completely at once. I don't have to count them in individually if I can do that easily in my mind. So 3 plus 4. Okay? Count them up. 1, 2, regroup, 3, 4. The answer is 7. Okay, let's try a different problem. Let's try 4 plus 6. Okay, I'm going to move 4 up, and now I'm going to count 6. 1, regroup, 2, 3, 4, 5, 6. And the answer has to be regrouped again. These 5 1 beads have to be represented by a 5 bead, and these 2 5 beads have to be regrouped into a 10 bead. So the final answer after regrouping is 10. Pretty simple. Let's try a little bit more difficult problem. Let's try 6 plus 7. So I'm going to enter 6, and we're going to do 7. 1, 2, 3, 4, regroup, regroup, 5, 6, 7. The answer of 6 plus 7 is 13. And you notice as we go through it again, 6, we have to regroup twice. 1, 2, 3, 4. Remember that number. Regroup, and then we have to regroup again because this is irrational, and then continue our count. 5, 6, 7. Answer is 13. Let's try 7 plus 6. Here's 7. Let's add 6 in the counting method. 1, 2, 3. Regroup, regroup. 4, 5, 6. 7 and 6 is 13. You notice I'm doing 3 things during the problem. Number 1, I enter numbers. I know how to represent numbers on the abacus. I know how to count up one bead at a time on the abacus, and I know how to regroup. And during the operation, if I have to, I will regroup to continue. And finally, I have to remember 2 numbers at once. And this usually occurs when you're regrouping. You have to pause the adding process, remember where you're at in the count and what you're counting up to, and do the regrouping, and then continue. Oh, let's try a 3-digit calculation, shall we? So let's just try. I'm going to pull this off the top of my head. 123. 123. And you notice I can enter those numbers as whole groups, or I could add the beads individually if I wanted to, but if it's easy for you to see that, it is quicker. 123 plus 456. 1, 2, 3, 4. Regroup. 50 and 6. 1, 2, regroup. 3, 4, 5, 6. 123 plus 456 is 579. Isn't that cool? 579. Boom. Easy enough to do. You only have to know how to do 3 things: how to count and add and represent numbers, how to regroup, and how to hold 2 numbers in your memory at any one time. Let's try another operation. 456 plus, let's say, 789. So 7. 1, regroup. 2, 3, 4, 5, 6. Regroup, regroup. 7. 8, or 80. 1, 2, 3, 4, 5. Regroup, regroup. 6, 7, 80. And 9. 1, 2, 3, 4. Regroup, regroup. 5, 6, 7, 8, 9. Regroup. And the answer is 1,245. So the same principles that I showed you for doing single-digit arithmetic addition, you can use on any size number at all. So thus far, we've talked about the counting method of abacus operation. It is very easy to do. It doesn't require hardly any skill or any practice at all. You simply have to know the 3 rules: how to count on the abacus, how to regroup when you need to, and how to remember 2 numbers at any one time, 2 single-digit numbers. Pretty easy, just a bare amount of practice, and you could become easily adept at this operation. But one of the problems with the counting method is it is slow. And this is the trade-off in the abacus between speed of operation and ease of use. Those are always competing kinds of requirements in the abacus. And the challenge when you become a really adept abacus operator is to be able to do both speedy calculations with ease of operation in your mind. And that only comes through training. But the next step up above the counting method is what I call the chunking method. And if we take our old problem 123, instead of entering each bead individually, 100, 10, 20, 1, 2, 3, you could instead enter it in chunks. 123. You do them in groups, whole groups in chunks. The chunking method of addition now will involve, instead of us adding individual beads, we're going to add them in chunks. So let's take our problem 123 plus 456 again. So we're going to do 400, and instead of adding each individual bead as an accounting method, we're going to move them in groups, the biggest chunks that we can in any portion of the rod. So 456, 400 comes up in one chunk, and then regroup. 50 is 3, regroup, 2, it makes 5. And 6 is 2, regroup, and 4 makes the 6. To make the answer, the final sum is 579. So let's take 456 and let's now add 789. So we're going to chunk this. So 700 is going to be 10, or 100, regroup, and 5 makes 6, regroup, and one more makes 7. 80 is 5, regroup, and 3. And 9 is going to be 4, regroup, and 5. And then finally regrouping again to make 1245. It's the same operation, but instead of you counting individual numbers, you can take them in chunks. Now, the trade-off with this chunking method is it does require a little bit more mental work, a little more practice, because it's not just 3 things you're doing. You're not just remembering 2 numbers at once and knowing how to regroup and knowing how to represent and count numbers, but you're also having to take the number you're representing and breaking it up into chunks and keeping an idea of where you're at in that count. It's just a little bit more work, but it's also faster. Let's take our old problem of 6 plus 7. We chunk the 6, and now we chunk the 7. 4, regroup, 7. Okay? Instead of counting them individually, we chunk them. It's a little quicker, just takes a little bit more work, but it seems to be quite a bit faster. So let's take our old problem of 6 plus 7, and we're going to enter 6 this way. That's how we represent 6, a 5 and a 1 bead. And instead of counting the 7 individually with beads and regrouping as we go, we're going to first of all look at the beads on this row that we have not yet entered and see if we can represent this next number by those beads. And it turns out 7, yeah, we can add a 7 directly. Then we can regroup to make the answer 13. Okay, let's look at that again. 6 and 7, instead of counting one at a time and regrouping as we go, we try to chunk it all in one chunk if we can, or as big of a chunk as we can, and then regroup to rationalize the answer, which is 13. Let's try the inverse operation, 7 plus 6. Can we add 6? Yep, 6, regroup to make 13. So we're taking it in chunks. Let's try another problem. I'm going to pull this off the top of my head. Let's try 12 plus 27. Well, there's 20 and 7. See that 5 and the 2? Directly 39. No regrouping needed. Isn't that cool? Let's try our other problem that we did, 456 plus 700. Now this is going to be interesting. We start on the left-hand most place value. By the way, that's different from doing addition on paper. In addition on paper, you always start in the units column and work your way to the left. No, on the Abacus, you start by the highest denomination, just as the number is spoken, 456 plus 789. You can enter the number as it's being told to you verbally. So 700, we're going to go 6, regroup, and 1 is 7. 80, directly regroup, and 9, directly regroup. We're going to have to regroup twice, and if you have this situation, you want to regroup the 5s first, so then you can regroup these, right? Makes 1245. Let's try 123. Remember, I'm entering those in chunks now, plus 456. 400, regroup, 56. Boom. Quick and fast. Let's add 789 to that. 700, regroup. 80, regroup. 9. We can't do 9. We can do 6, regroup, and 3 is 9 to make 1368. Well, this is the easiest possible way to learn to add on the Abacus, and this counting method essentially works on any of these versions of the Abacus. I showed you the 2-5 configuration from ancient China. The counting method works great on any one of these. Now, the 1-4 Abacus and the 9-bead version of this 10-bead Abacus here. The 9-bead Abacus and the 1-4 you don't actually do regrouping on because you can only represent 0 through 9 on each rod. These other two you have to do regrouping. So I'm going to be showing you how to do the counting method in a next video using the 1-4 Soroban and the 9-bead Abacus. But the counting method is really easy. You just got to know how to represent numbers and count on the abacus. You have to know how to regroup, and you have to remember 2 single-digit numbers at any one time in your head. And I hope you guys take the challenge of this and pick yourself up a little abacus, even if it's one of the more primitively built or crudely built 2-5 Chinese tourist abacuses with the round beads instead of the biconic Japanese style. Get yourself a 2-5 abacus to start with. They're actually pretty easy to start using. And I'll give you another tip. Take your grocery lists, your receipts that you get from the store, the grocery store, or any other stores, save them, and then start practicing adding them up. And you can actually verify the math that the checkout clerk used on their cash register. And it's really good practice. Of course, you'll rarely ever find an error in a commercial retail cash register device, but it's fun nevertheless to use that as an opportunity to practice your abacus skills, and the counting method is the ideal way to get started with the abacus. Very easy, very few things you have to remember, and it is slow. It's slower than the really highly efficient Japanese soroban method that Kojima talks about in his books, but it is easy to get started with the abacus, and it's fun, really. I'll leave a link down below for Kojima's 2 books if you're interested in those. And until next time, I wish you guys the best and stay creative. Bye-bye for now.